The famous Daniel Bell once said, "Technology, like art, is a soaring exercise of human imagination. Any sufficiently..." Yes? Okay, thank you. Any sufficiently advanced technology is indistinguishable from magic. With a focus on electrification, automation, and digitalization, Siemens India stands for engineering excellence, innovation, and reliability. As one of the world's biggest producers of energy efficient and resource saving technologies, Siemens is a pioneer in infrastructure and energy solutions. With this, I'd like to welcome our keynote speaker, Mr. Vivek Kanade, the esteemed panelists, faculty members, fellow Christites, and the audience who've joined us through live stream. I am Kirtana, and it is my privilege to be your moderator for this session. Daksh is an educational career guidance fair organized by the Student Council of Christ Team-to-be University. It focuses on various opportunities made available to pre-university, undergraduate, and postgraduate students. The platform enables students to acquire knowledge and make informed choices regarding their higher education and careers. Career Dialogues is a feature of Daksh, wherein eminent and established figures from diversified fields are invited to share their invaluable experiences and accompanied with their expert opinion. It gives me immense pleasure to introduce our speaker for this session, Mr. Vivek Kanade, who will be gracing our occasion with his insights on career prospects in the field of engineering, information technology, and healthcare. Sir is an executive director at Siemens Healthcare India, handling business of Zone India and neighboring countries like Bangladesh, Nepal, and Sri Lanka since March 2016. Before taking up this role, his last assignment was as Vice President Global Sales and Marketing, Siemens AG, Germany. Sir started his career with Hindustan Motors in 1992. During his association with Siemens for over 28 years, he's held various positions across diversified functions such as sales, service management, regional management, and modality management. Sir firmly believes that one's own will to adapt, upskill themselves, and to leave their comfort zone are some of the essential qualities that graduates need to imbibe into themselves to sustain in the industry. Sir, we're very excited to hear from you. Before I hand it over to you, sir, I'd like to point out for the benefit of the audience that any questions for the speaker can be posted in the comment section of the YouTube Live. Without any further ado, I humbly request you to begin with your talk, sir. Over to you, sir.
Thank you. Thank you, Kirtana. Hello, everyone. Let me share my screen and then we can begin. And as Kirtana said, let's try and keep this interactive. If there are questions, please put it in the comment section so that Kirtana can share them with me, and I will try my best to answer. And I am looking forward to a lively session in the next 1 hour. So let me share my screen. Okay, Kirtana, can you just give me an indication if the screen is visible?
Yes, sir, it's visible.
Okay. After reading this, I'm sure how many people in the audience have become invisible. Don't worry, guys. I will take you through a much smaller slide set for those people who are still remaining as audience. Moving. Okay. Okay. Let me go back to 25th of March. That was the day when this lockdown was announced. And of course, some guys were overjoyed. Happy holidays, college closed. Some guys started working from home. The streets were empty, and mostly many people started lazing around. What did it mean for us as health engineers? We are part of the healthcare group, and thus we saw chaos. It was pure chaos for us. Let me take an example and then I will explain what it means. I'm sure many of you would have heard what an MRI machine is. MRI, magnetic resonance imaging. It's this big machine with which you image your body, the size of a room. This magnetic resonance imaging machine has this magnet, which is quite large, and this magnet needs liquid helium to be kept cool. Liquid helium is at a temperature of minus 270 degrees. Yeah, and this whole magnet has to be immersed in liquid helium, and that's why it has a huge tank and it is filled with liquid helium. On March 25th, there were 14 of such MRI units which were on their way to their customer's place. And once the lockdown was announced, all of them more or less stopped on the way, whichever part of India they were. Let me take you through the journey of one such magnet, which was stuck on the outskirts of Guwahati. It was on its way to Imphal. We got an SOS call on 26th from this guys who are on the truck. It is a big trailer which is going, saying that, sir, the helium level has gone down considerably and we are stuck here and we are not allowed to go further. So I think we need helium. And then the scramble started. Our helium supplier, so helium, as you can see, I will use some pointer options. The helium is stored in a flask like this. I mean, it's not a small tea flask. It is at a height of 5 feet and carries about 500 liters. So this is a flask used to carry liquid helium. So it is kind of at minus 270 degrees inside. And this helium supplier was in Pune and he was shut down by the local authorities saying that you are not part of essential services, so you can't operate. I mean, it is so difficult to convince the local authorities and police guys, right? They must be thinking, what is this tank and helium and all this got to do with healthcare? But for us, this liquid helium and this Diwar, as it is called, it's called a Diwar, not a flask. This Diwar was a life-saving item. The magnet which was on its way to Imphal was worth about 20 crores. And if the liquid helium evaporates from the magnet, then we are going to lose a lot of money on that. So we started scrambling, running from pillar to post, finally got Chief Minister's office involved and got this Pune plant open. And that, as we realized, was only the first step. Because as you can see on the right, from Pune, we needed to cross all these states and go up and then reach Guwahati. You need about 10 of these diwars to be filled. So it's a truck full of these diwars and they need to go fast as well because minus 270 degrees in a flask, in any manner, it will keep evaporating because there's no active refrigerating system here. So what we did, we got two of our colleagues plan this whole route, take all the papers together and made sure that our colleagues were there at each state border for a handover. So the truck was going, our people were following it up, following the truck. At state borders, they made sure that all the relevant documents were shown and the truck was allowed to cross the border. And it took about 9 days with all the different authorities stopping, starting, district authorities stopping, starting, before the truck finally reached Guwahati. And this picture on the left is what you see, the first Diwar coming onto the trailer, the very desperate situation where helium was required. And our people had to fill helium right there in the middle of the road. And then started the journey. Our service guys stayed with this trailer through Guwahati in this traffic jam, and then they reached outskirts of Guwahati. There was a big landslide, as you can see. These are actual photographs taken by our service guys at site. We had to navigate through these obstacles, and then we hit the bad patch of roads, as you can see. A small video clip to show very extreme roads, how it is being done, and the police has taken up this place. Our engineers are sitting in the truck monitoring the situation. And then after 4 more days, they reached the site, and locally nothing was available. And you can imagine now, 25th March onwards, everything was locked. There were no restaurants, there were no hotels, there was no shops open to get things, tools that were required. So everything was closed, and our team really had to do makeshift arrangements, literally jugad arrangements with anything and everything that they did. Entire took a break.
नहीं में देखो ना क्या क्या इसका कवर टूट गया तो ये डस्टबिन लगा दिया
Using the dustbin cover where it is required. I mean, this is purely jugad India, right? I mean, when things get tough, we get going, and we our guys had to face a lot of hurdles. They slept in the truck throughout this journey. They stayed with the drivers. They slept in the truck. There was no hotel. Food was difficult to come by, and finally, when they reached Imphal, they got rooms like this in the hospital to stay, because then the work started, and they would be there for the next 15 to 20 days. So they had to kind of manage with this. I will also show you audio, because you saw the trucks going through this difficult roads.
दे थोड़ा
The
साइड हो
most
जाओ खाली
important, this will be the most important video for every guy back in Siemens Healthineers to see the status as green, yeah, which was blinking green, which is the stop detector on the magnet. And if this had turned red, then our entire magnet would have to be scrapped. So finally, 20 days later, as you can see, finally the first images from this MRI. Yeah, and it took 20 days of extremely hard work finally before we could achieve this result. And what makes our people do this? What makes our people to sleep in the trucks, search for food? I think clearly the 7 principles of healthineers, what we call, we live, Siemens Healthineers live by the 7 principles of healthineers, which is what are stated here. And you see right in the middle is our first principle. A day without passion for healthcare is a lost day. I think that is what drives us as people. That is what drives us as a company. Because at the end of what we do is a patient, is a needy patient for whom it's a matter of life and death. So what we do day upon day is save lives. And I can tell you with pride that each and every person who works for our organization is as passionate about delivering healthcare as the guys who are on the truck the other day. With that said, who are we in India? We have our presence in about 56 locations in India. Uh, about 1,000+ employees work for the sales and service organization, that is the distribution organization, as we call. We sell units and we service them through their life cycle. So that's about 1,000 employees. We are also deeply engaged into R&D activities, software development, modules development, I can say with pride that every Siemens system that is installed in the world is touched by one way or the other from this building here, what you can see on the right. This is right there in your place in Bengaluru. This is at Electronic City. And here, 2,800 of our passionate employees work in the R&D center. We also have a manufacturing hub, which is also at Electronic City, but a little far away from this current place where what you see in the picture, where we manufacture CTs and C-arms, and we are also going to manufacture MRIs in the next 1 year. I'm not sure if you had a chance to see the news recently. Siemens Healthineers announced that we would invest about 1,300 crores in creating a brand new campus in Bangalore. It will come up right opposite to Narayana Hrudayalaya today, which is in beyond Electronic City in Bangalore. And this is a 12-acre campus which will house manufacturing, which will house digital innovations, which will house our R&D activities, and our headquarters, which is currently in Mumbai, where I sit, will also shift to Bangalore shortly. So this campus will become the powerhouse of Siemens in India, the Healthineers in India. And how do we serve our patients? What are the units and the departments that we have? So right from ultrasound to X-ray units, to computed tomography, which is the CT scanner, magnetic resonance, MRI scanner, nuclear medicine or molecular imaging, and lab diagnostics. So if you look at the diagnostic space, suppose you go to your family doctor. After he checks you, whatever tests he asks, we are sure that we are in that domain to perform. Whether it's a blood test, whether he says do a complete blood check, check your glucose, sugar, calcium, whatever on the blood test, or if you need something like a CT scanner or an X-ray or an MRI, all diagnostic domain Siemens Healthineers is present. So we do 100% of diagnostics, which no other company in the world can boast to do. Where it all started, the year is 1895, and a professor called Wilhelm Conrad Röntgen, the man in the picture here, at the University of Würzburg, first discovered X-rays. Of course, at that time it was not known as X-rays. He discovered strange rays which were capable of doing imaging of a human body. And this picture you see on the left, this is his wife's left hand. So this was the first ever known X-ray image done by the discoverer of X-ray, Dr. Röntgen. And within 1 year of this discovery, at that time, Siemens was known as Siemens and Healthcare. These were the two families who came together to create this current Siemens entity. Siemens and Healthcare introduced the first ever X-ray machine in 1896, 1 year after the discovery of X-rays. So that was absolutely fast. And today, how the X-ray machine looks like since then is this.
With traditional X-ray, complex radiographic examinations are often challenging or cumbersome, especially in musculoskeletal or trauma cases. Meet Multitom Rax, our high-performance twin robotic X-ray system, supporting your technologist and radiologist in daily clinical routine and beyond. With Multitom Rax, We are bringing a wide anatomical coverage and high precision together. Accuracy is at your fingertips, allowing projections from nearly all angles and unique automated workflows that make musculoskeletal.
Okay, so I won't go into, I mean, this is not an advertising talk, so, but I just wanted to give you a sense of how the change was between the first X-ray machine and what it looks like today. Similar with the ultrasound. Ultrasound was introduced in the year 1967. What you can see on the left, and it was a big room, a whole room, and it used to take a couple of hours before you could get some kind of an ultrasound image. And today, within a few minutes, you have crisp and clear images. So, from a technology perspective, we have moved through a millennium at this time. Here is a picture of the first ever CT scanner in the world. This is actually the first. On the left, what you see is the first CT scanner in the world, and this is a actual picture of the first scanner, introduced in 1975. And this was absolutely what you see, the image below, the first image of the first CT scanner in the whole world. We are proud that it was a Siemens unit. It was called Ceratome. This, what you see here, is a slice of a brain. Yeah, so if you slice the brain, this is how, or if you slice this, your face or skull, this is how the brain looks like. This image took over 5 minutes to get. Each single slice took over 5 minutes at the time. And today, on the right hand side, what CT scanner you see, this image comes from this CT scanner. It will show you a 3D image of a heart and also one slice of the heart and the artery. This image is less than 1 second. This image you get almost like a photograph in its 3D format. It's just mind-boggling the kind of data that goes into creating this image. So from 5 minutes for one single slice to 1 second or less for an entire anatomy. And that is the progress that has been made in the last, let's say, 45 years at the moment. Similarly, the first MRI machine of 1983. You can see how it looks and how it looks now. And this is a case where we recently introduced Vascular Robo. Yeah, what you can see in the picture here in about the patient is typically the cardiologist. I'm not sure how many of you have heard or known or seen ever a procedure either in a family or friends and acquaintances. So when people have a heart attack, that means there is an artery which is blocked, and this blocked artery is either opened by a balloon and kept open by putting a stent. Stent is some kind of a small segment of a pipe that is placed in the artery. Um, till date, this was done manually. So this person, the doctor here, used to actually stand here next to the patient and insert the catheter, what we call it's like a pipe, insert at the level of the femur, and this travels the pipe or the catheter travels, the tube travels all the way up to the heart, and then you send a small stent from here and place it in the heart here. While at the same time, this is an imaging system here, and here on the monitors you can see. But today we have the possibility to do it entirely robotic. Yeah, so you can actually minimize the human error quite a lot, increase the accuracy quite a bit. So this is the advances from a human being trying to insert a tube into a patient to now what a machine can do. So what are the new age trends? in healthcare imaging. Yeah, clearly, as you all know, everything is driven by digitalization. So now we have moved away from a pure hardware engineering type of outcome uh, to where digitalization can kick in, and that can kick in up to scale. So once you move into the digital world, um, it's all about scale. Yeah. So what are some of the things that we are doing in our field? To explain this, let me give you an example. We have a customer in Brazil. I will also give a Indian example in a minute, but let me start where this whole thing began. There is a customer in Brazil of Siemens Healthineers who owned 70 MRI machines from us, 70. And this customer had installed these 70 MRI machines across the small towns in Brazil. And it was extremely difficult for him to get a good technologist to run the machine, because a technologist, the machine is only as good as a technologist. So the technologist needs to be highly skilled to operate these units. And he was facing trouble in getting good technologists at his remote centers or the rural towns. And depending on their skill sets, some technologists were taking 1 hour to finish one patient, some were taking 30 minutes to finish, and some 15-20 minutes. And accuracy wise also, it was kind of across the spectrum. So there was no standardization at all. So what we went and did is, through digitalization, we created a virtual cockpit. So we created a central command center in Sao Paulo. So you can imagine now this is Sao Paulo with a central command center where about 20 highly skilled technologists could sit. They each had a pair of monitors and they were connected directly to the machine, and they could operate the machine sitting in a central place. And they could be trained very well. They were all in the city, so it was easy to hire talents. And standardization started happening across all the 70 sites. So people who are able to scan only one patient 1 hour were now able to do 4 patients in 1 hour. And all this happened through a regular, normal, retail available broadband. So we fine-tuned this concept, and this concept is now live across the world. In India, we have one of our largest customers called Aarti Scans in Chennai. If people from Chennai, you might have heard about Aarti Scans. He has 20 scanners installed in and around small places in Tamil Nadu, in Chennai as well. And here we have set up this thing, a central command center. And overall, it makes the business has increased threefold. And what's happening is the patients get the best quality outcome when there are experts scanning on you. This is also during the COVID time. I would like to give an example what we did. Trivandrum, there is a famous institute called Sri Chitra Tirunal Institute of Medical Sciences. Here they had allocated one CT scanner to scan only COVID patients during the lockdown, meters away. So then there were no requirements of PPE kits. Safety of the personnel who were scanning the patients was guaranteed, and so it went quite safely. To the normal, I mean, to a youngster, it may not sound so. What's kind of great about this? but to actually do the scanning remotely, connecting remotely, connecting via video is one thing, but actually to do a scan sitting in a remote place, it's like a doctor, you are getting a surgery done in Bangalore, and the doctor is sitting in United States doing the actual surgery, but there is a robotic unit doing the surgery on you, but being controlled by a doctor in the United States, an expert. Yeah, this is what this is. So it is a big thing in the field of imaging. All of you have heard this. We've been working at it for quite a long time now. Siemens Healthineers actually owns a supercomputer. There are very few companies in the world who own a supercomputer, and believe me, it's the size of two small apartments, not too small, but two, you can imagine two 3 BHK apartments in Bangalore, and the size of the supercomputer is exactly as big as that, about probably 4,000 or 3,500 square feet. And Siemens owns this supercomputer, and Siemens has used this machine to develop algorithms revolving around artificial intelligence. Artificial intelligence clearly works in a way garbage in, garbage out, right? So probably you might already know that. Your output purely depends on how good your input is. How good your machine learning input is, your output is as good as that. And currently we use 800 million 800 million images of curated data, 800 million images of curated data to come up with algorithms. That's really mind boggling. At the end, what does it do? It does things like this. Yeah, you do not need now, for example, take this center image. Yeah. So this is a sliced image of your body, and this is your spine. Now you don't need to annotate, you don't need to start counting which is your C1, C2, or C3, C4, or C5, or T1, T2, T3. The machine, as soon as it scans, it already identifies all the vertebrae, it identifies if there are issues, if it points out the different lesions in the body or anomalies to say, and all of this report is given to the doctor so that the doctor can look at it and decide whether what kind of treatment. So all of this which was being done manually is now being done through artificial intelligence. And this is only a baby step. Going ahead, we are creating what we call as a digital twin. Unfortunately, it's under confidential data set right now, so I don't have images. I would have loved to present you those images, but let's try to imagine it. Yeah. So I am Vivek. I feed all my historical histopathology data. That means my blood pressure, my heartbeat, whatever problems I had before, whatever reports I have, my height, my weight, my fat content, all of this I feed into a digital twin of myself into the computer. Yeah. And this twin of me, that is Vivek's twin, grows along with me because it has all the parameters fed into it. And whenever I do any medical test, automatically this goes into the digital twin, and the data is then reset. So what happens over a period of time? Just imagine that tomorrow I have a complex disease, and there are two or three different um, prescriptions or procedures that can be used to treat me, right? Now, instead of trying by trial and error, let me try this first or let me try that first, I try it on my digital twin. I try it on my digital twin and see how the digital twin responds to different types of treatments, right? And then you will know what is the best form of treatment to be given based on the response from my digital twin. And then that treatment can be applied to me. For example, today we are all talking about COVID vaccine. If I had a digital twin, I could have given the vaccination data, right? A digital vaccine of whatever is being injected, I could have injected in the body of my digital twin and seen whether antibodies are developing or not, or how long it takes for vaccine A to develop antibodies or vaccine B to develop antibodies. Which vaccine is more safer for me? Do I have an allergic reaction? Do I have an adverse event on my digital twin? I could test all of this before I take. So that's going into the realm of precision medicine and personalized medicine, because all bodies do not react exactly the same way in healthcare. That when you go deeper, you will realize that each body has a different way of reacting to a certain medicine, and it's all going to be about personalized and precision medicine going forward. So this digital twin, when we finally come out and create these digital twins, are going to be immensely helpful in saving lives. So that's there we are traveling, and it's a very, very exciting world out there. Despite all this changes in technologies, despite all the advances that we have done, can you guess one thing that has not changed at all in all these years? That's the patients. The expectation from the patients has not changed. We are continuously striving to create technology to give quality healthcare to these patients, but at an affordable cost. And I think that is significantly important as we go ahead. And that is exactly what keeps us as a Healthineers team awake at night, because our focus is not selling this one unit to this hospital or that one unit there. Yeah, we are trying to create units. We are trying to invent technology that can finally give the patients the relief that they need. And that has been our commitment to the society. It's 120 years of Siemens Healthineers, 1895 onwards. Till now, we've been delivering quality, we've been delivering excellence, and we've been delivering it with absolutely passionate people. So if you are that passionate guy, if you want to do something for the society, and if you are a technology buff, then Healthineers is the place to be. Yeah, and with that, I would like to end my talk, and thank you very much for a patient listening. And now, if there are questions, I would like to take them up.
Thank you, sir, for your interesting talk. I'm sure the students and the audience would have earned an extensive amount of knowledge about Siemens, its principles, functioning, and market presence, and also for showing us how technological advancements have led to faster healthcare services through your presentation. And the concept of digital twin was something very exciting and new for all of us. Before we move on to our Q&A session, I'd like to announce that the Google form for attendance will be sent on YouTube Live. We would like to proceed with the Q&A session now. Sir, shall I read out the question, sir?
Please go ahead.
How easy or how difficult was it to create and implement automation in healthcare when the pandemic just started?
How easy or difficult was it to create automation in healthcare?
Yes, sir.
Okay, so one thing we need to realize is that every thing that you do in healthcare touches a patient's life, yeah, and it can create a difference between life and death. So it's not easy to experiment. You know, we can't create a software and start immediately delivering it to the market. It's just impossible. We need to be more than 100% sure that it does absolutely no harm to any patient, and that is the first criteria or first oath that any doctor takes. Do no harm. Whether you treat the patient or not, do no harm with your treatment. And that's why there are, across the countries, regulators making sure that every bit of uh, software, hardware, anything that touches the patient is highly regulated, and it's not very easy to get past regulations unless they are totally convinced. So doing something very quick and easy, um, like like the automation stuff that I talked about, meaning remote connections, uh, uh, was typically easier because it was only working with a scanner that was already approved by the regulator, so it was only an extension to that scanner. But doing anything else was extremely difficult, and it takes time within healthcare, so you need a lot of regulatory approvals. Yeah.
Yes, sir. I'm sure that must have answered your question. So may I move on to the next question?
Yes, please.
How are data science and AI as careers for cross-industry roles? Does Siemens hire in those areas?
Sorry, I can you come again with the question?
Yes, sir. How are data science and artificial intelligence as careers for cross-industry roles? Does Siemens hire in those areas?
Yes, data scientists are very much in demand, because you have today a humongous amount of data, and you need to be able to make sense from patterns within this data, because it's not that we have four images and we can decide what's the best way. We have thousands of images, and it is beyond human capability to look through 1,000 images and then decide on a diagnosis. So patterns come into picture, data science comes into picture, analytics comes into picture, and I would say, I mean, the base, the foundation of healthcare or health engineers is like software, electronic, right? It is used for healthcare, but what components you use to create a TV are also components you use to create a CT scanner machine, right? What components you use to build a truck are also the same things that are used probably in a MRI machine. It's just that it is done with higher precision, and outcomes are more robust than what you do it in a truck or in a TV. But the component wise they're same. So the foundation, data science, is doesn't matter whether you are using it in energy or automation, or auto industry or healthcare industry. Foundation, if you have experience in data science, you are definitely a valuable person for us. Similar is with the software development group as well.
Yes, sir. Shall we move on to the next question, sir?
Mhm.
Uh, how do we bridge the gap between medicine practitioners and technologists? That is, how do we train technologists on medical concepts and medical professionals on computing?
How do we train?
Yes, sir.
I mean, it is the same thing, as you see in any other part of life. Technology adoption, right? The rate of technology adoption is similar in healthcare, because ultimately we are all human beings living in the same society. So, for example, my parents are averse to going on to social media or averse to even using WhatsApp for communication, though I can do it, and I am averse to going on Instagram, and my daughter does it day in and day out. Yeah, so it's the same in healthcare. You have a set of clinicians who are absolutely averse to using technology, and you have one set of younger generation clinicians who don't have enough of technology. They are demanding more, and this is going to remain this like a generation gap. It's a generation gap on technology. Yeah, this will remain. But what do we do is we need to make sure that we bridge this gap with extensive training. So uh, we have an extensive training programs for all the healthcare professionals, whether it is paramedical staff, whether it is nursing, whether it is doctors, or whether it is surgeons. We have extensive training programs across all our in the whole domain that we are present, and we even have training programs that we can deliver in colleges like yours. So we have programs for biomedical, we have programs for electronics graduates, we have programs for different things where we can deliver these so that we try and create a faster learning curve, so to say. Yeah, but the generation gap is going to exist as long as there are two different sets of adopters.
Yes, sir. So shall we proceed with another question, sir?
Yes.
Making a digital twin would require a lot of computing power, which would lead it to be very expensive. What would it be feasible for normal? Would it be feasible for normal patients, or would it only cure diseases to those who, to the ones that don't have a cure yet?
So, I mean, creating a digital twin is honestly currently a dream. Yeah. When I say dream, there is a lot of work going on, but it is still a few years away before we can healthily make a healthy digital twin, so to say. Yeah. Because if I start at my age creating data, maybe I don't benefit much. But if there is a newborn and you create on the day there is a newborn and you create a digital twin of the newborn, you first enter the data right from blood group, RH factor, the height, weight, sex of the patient, of the child, all of this, and then start as soon as you measure every 6 months, then you give this vaccination, that polio vaccination, MMR, and all that. So the data builds up. The better the data in the digital twin, the better the outcome. And I think it's only it's a matter of time. I honestly believe it's a matter of time before each and every one of us will have digital twins, um, going into the future, and that is the way to go, because you can then do all the experiments of personalized medicines on digital twins. The idea of a digital twin is currently what happens, many of us feel that you have fever, you take crocin. Yeah, it is fine because it impacts everyone. It relieves everyone of fever. But as you progress in medicine, this is not the same. I will give you an example. uh, Breast cancer. Yeah, there is a certain drug for a breast cancer that is totally ineffective on Caucasians. So if there are two ladies with breast cancer, one from Europe and one from, let's say, Asia, right? And if you inject this drug into these two women, one will get completely cured, and the other, there will not be a single point of improvement, right? So this is very, very personalized. Now this can happen between two races, and if you go deeper and deeper, you will finally find that it is absolutely a customized, personalized need for medicine, and that's where I think digital twin will help. It is going to play a big role in how we are treated going into the future.
Yes, sir. That sounds exciting as well as essential. So, shall we proceed to our last question?
Yeah.
We have a few more questions, but due to
Mhm.
time constraints, we'll take up one last question. I'll pick the last question we recently got. What are some of the current challenges faced in the healthcare industry, And what can young graduates do to be productive hires in this space?
There are a couple of things. I think one is learning. I think freshers have to spend a majority of their time learning. Coming out of college doesn't mean that now you are experts and now you will be able to start becoming productive. I think learning is something that one has to do throughout his or her life, but especially now when it comes to technology, the first few years have to be spent more on learning rather than doing. The second thing is, I think if you need a fulfilling career, I would, all with hindsight I can talk, um, do not jump from company to company in a short span of time. Over a period of time, you will you will not have the satisfaction of having learned something deeply, becoming productive in something deeply, because this is a natural phenomena I see though in these years. Everyone wants some change in 2 years or 3 years. I think important as a young graduate to really focus that you have approximately 40 years of working life, and you need to be able to space out this 40 years and fill this 40 years with very, very meaningful learning, meaningful expertise. So my suggestion to everyone would be, choose a job carefully, choose a job that you like to do, but stay on, and things will automatically keep changing, even in the company that you're working for. Of course, if the company is troubled, as has is going bankrupt and things like that, it's a different case. But I would strongly encourage you at least not to move jobs just because somebody is paying 10% more or 20% more. Yeah, look at the role fulfillment. I can tell you out of 30 years now of experience in this.
Thank you, sir. That was a very valuable advice. So, shall we pick another question, sir? The last one.
Yeah, we have time, another 6 minutes, so we can
Yes,
do
sir.
that.
Not sure which one to be picked. Okay. Even though technological advancements in this field are a boon, won't it lead to a loss of jobs?
No, I honestly believe the answer is no. I will give you a very basic example. 400 years ago or 300 years ago, yeah, we don't have a count. When in United States, 98% of the population was into agriculture. United States of America, 98% of them were doing agriculture, 2% was doing some other jobs. Yeah. Turn around the situation today, 2% of the population is doing agriculture and 98% of the population is doing something else. So if you view back in history, the advent of a tractor, right? A farmer, instead of 10 people in the family and 20 bullocks in the family, yeah, they replaced with one tractor. Yeah, and then exactly these were the thoughts. What will happen to the other 9 members of the family and the 20 bullocks? Yeah. But history has taught us this continuously, that uh, a change in technology opens up different other avenues of jobs. Yeah. So for example, Uber or a Ola has opened up opportunities for drivers. A Zomato has opened up opportunities for delivery boys. Yeah. So the nature of jobs will keep shifting. Of course, the nature of that particular job will keep shifting. But I believe with every advent of technology, you will have more jobs being created. So we shouldn't be frightened of technology change at all.
Yes, sir. So if you don't mind, can I pick another question? I promise this would be the last one.
No, we have time till 4, so I'm okay to answer some more questions if there are, till you have to go to your next session. Yeah.
Yes. Is the shortage of semiconductors in India today affecting Healthineers today? Are there any steps Siemens has taken to ensure no further shortage and its development in semiconductor fabrication?
Actually, see, there is, I wouldn't call it a shortage. Yeah, in the world, we are a global company and we look at the world. So there is no shortage of semiconductors in the world, but there is a shortage of manufacturing semiconductors in India. Yeah, and that is something which we as a company have been addressing various government organizations, saying that you are asking us to locally manufacture, but we can't manufacture everything. So let me give you an example. A car manufacturer, there are about 800 different parts in a car. And do you know, a Hyundai or a Mercedes Benz or Maruti Suzuki, any car manufacturer you take, or Toyota in Bidadi, how many parts they manufacture in a car? Not more than 20. Out of the 800 parts that a car needs, the car manufacturer manufactures not more than 20. And this is the rest of the 780 parts have to come from vendors, right? The manufacturer will not be able to manufacture. So me as a healthcare company, I will not go into manufacture resistors, capacitors, ICs. Yeah, this is not my core expertise, but I want them manufactured by vendors so that I can buy from them and create something which is made in India. And I think that vendor ecosystem has to really develop in India. Today we don't see it in healthcare or in the electronic industry, and that is something we sorely miss when it comes to manufacturing in India. We have been lobbying with the government to create an ecosystem where semiconductors, valves, X-ray tubes, image intensifiers, all of these can be manufactured by vendors in India.
Thank you, sir. So due to time constraints, unfortunately, we will not be able to take up any more questions from the audience, but we'll definitely appreciate your active participation in this session. Thank you, sir, for answering those queries.
Thank you very much. And whoever has been patiently listening, have a good day, and yeah.
Yes, sir. I'd like to propose the
Look
vote of
forward.
thanks now, sir. Shall I proceed, sir?
Yeah, please go ahead.
Feeling gratitude and not expressing it is like wrapping a present and not giving it. I'd like to express my profound gratitude to everyone who has contributed to making this event a successful one. On behalf of the University Student Council and management of Christ Deemed to Be University, I take this opportunity to thank our keynote speaker, Mr. Vivek Kanade, for taking out time from his busy schedule and gracing us with his presence and enlightening us with his deep-rooted knowledge. I'd like to thank the Controller of Examinations, Professor Johnny Joseph, sir, who's always inspired and encouraged us. Heartfelt thanks to Dr. Suja ma'am and Roy, sir, for their continuous guidance and motivation. I'd like to acknowledge and appreciate the efforts from fellow University Council members who are part of events, technical and logistics committees for their consistent support, without which smooth conduct of this session impossible. Last but not the least, I thank all Christites present and external participants for joining us and being such wonderful audience. The session is officially concluded. Thank you all. Thank you, sir.
Thank you.